Welcome back to Smith Coding and Design. So in today's tutorial, we are going to go over the creation of the soft jaws for our microARC fixture plate. And so what we're going to take advantage of here is some of the soft jaws that we already made from the ashtray tutorial. So we made a nice Vise model that had a set of soft jaws that hold 4-inch round stock, as well as a piece of parametric stock that we have in the jaws of our vise that gives us some flexibility to go ahead and insert our models into it. So we're going to save a lot of time by reusing this model. So if you don't have this model already, please go and view the soft jaw tutorial from the ashtray series. And so what we need to do that's new is we need to go ahead and make our soft jaws for Op2. So I have the vise with just the soft jaws in there ready to go. We also have our joint origin in the center. So all that I am going to do, and again, we worked on this model in some of the previous tutorials, so you should at least have an idea already of how to get a vise set up with a set of soft jaws that have the gap between the jaws parametric, so we can go up to change parameters and change the gap we want the soft jaws to be. And in fact, for this part, we want them to be 3 inches apart, so I will go ahead and enter that now. And again, we have our joint origin, and so if you don't remember how to add a joint origin between two faces, you would essentially just go up here to a symbol and then select your joint origin, and then you could add it there. Again, look at the previous tutorials. I'm trying to save some time by not going over everything each time. That would bore you guys. So let's move on. The next thing you want to do to go ahead and make our soft jaw. So we adjusted our jaw gap from our parametric model here to 3 inches. Now we want to go ahead and insert our microARC fixture plate. So we'll insert that, bring it up, we'll go ahead and rotate it 180 degrees. That looks good. And we'll rotate it again 180 degrees, and we'll just pull it up out of the way. We'll hit enter. We'll go ahead and minimize that. Go back to our home view, and now all we need to do is orbit, and I'm going to press J for joint. I'm going to click on the center there, and then again, the beauty of having a joint origin is it becomes simple. We simply joint our part to the joint origin, and then what we want to do is go ahead and move it down in Z by 1/4 of an inch. So I'm just going to go over here to my Z offset, and I'm going to enter minus 0.25 and press OK. So there we go. Now we have our model inside of our soft jaws. Right. So what I'll go ahead and do is go back to the home view so we can sort of see things better. And what we want to do again is just go to combine. And then what we'll do is we will go ahead and select our target body. So we'll start with the left soft jaw, or the soft jaw that is on the moving vise jaw. So we'll select that. And then for our operation, we want to perform a cut, and then we'll select the tool body, which will be the part itself. We'll press OK. And then what we'll do is we'll go ahead and minimize our part. Go back to our home view orbit, and you'll notice we just need to get rid of this feature here. So again, I'll press E for extrude, and we want to bring that down minus 1/4 of an inch. So there we go. We have our soft jaw. And so if you remember from the overview video, let's go to the right hand side view here. There's this flat spot here. So actually all that I needed to do was just machine the soft jaw that's on the movable side of the vise, and that does it for our soft jaws for Op2. So it's nice and simple. This locating feature made our job pretty easy. So what we'll do now is we'll go ahead and jump into the cam. It's going to be very simple. So now what I'm going to do is go ahead and jump to the manufacturing tab. And then we want to go ahead and create a setup. So I'm going to right click on setup, new setup. We'll come over to the stock and we will go to from solid. And then what we'll do is just go ahead and come over here and select our Vise jaws. Then we will go back to setup. And what we want to do here is go ahead and select our WCS origin. So I'm going to go ahead and hide our part for a minute. That way we can see. And I'm just going to use the upper left corner on the fixed jaw side of our vise. So this is where WCS origin will be. The next thing I want to do is go ahead and select the model. So for the model, it is just going to be this first vise jaw, right? This one is just flat. This has our locating feature, so I'm just going to machine this one. And then we're going to enable fixture, and I'm going to select the second soft jaw as well as all of the vise components. And then lastly, I'm just going to go over here and into the post processor tab and give this a name. That way when we go ahead and we post and we generate our G-code file, it will have the name there for us and make life a little easier. I'm just going to call this soft jaw op1. All right, so we will press OK, and there is only one op, so that should be fine. And again, I guess before I press OK, always make sure your axes are pointed in the right direction for your machine. So let's go ahead and press OK. So our setup is done, and I guess what I should also do here is just name our setup. I'm just going to call this soft jaw setup. There we go. And now we'll go ahead and start the cam. So what I want to do is go ahead and come over here to 2D adaptive clearing. I'm going to go to my Tormach tool library and select my 3/8 inch Gorilla chimp breaker. This is typically what I use for roughing. We are running at 7,500 RPM, 60 inches per minute, and almost 3 thou per tooth. The surface footage per minute is there if you're interested. So there's all the parameters that I'm using. We'll now go into the geometry, and let me just go to the right side view here, and then we'll orbit just so it's a little easier to see. And I am just going to select this face. This is our only indicating feature in the soft jaw, so that is fine. That's all we need to do. We'll now go to heights. And we always want to make sure our heights are fine. So we're going to start machining from a top height of the stock top, which is correct, to our selected contour, which would be this face here. So I think that is fine. We'll now go to passes. The most important parameter here is the optimal load. If I were to leave that 150 thousandths, at least for my machine, I would stall my spindle. So what I'm going to do is put that somewhere around 10% the diameter of the end mill. I'm using 8% in this case, which is 30 thousandths. Stock to leave, I could leave that at 20 thousandths and that will be fine. So now let's go to our linking, and typically what I do here, even though we're probably not going to perform any type of helical entry, I like to get into the habit of always making the ramp clearance height at 20 thousandths. And so if we hover over this, what this is just showing you that it would start 20 thousandths above the stock to perform that entry, just so that we avoid cutting a bunch of air. So now what we will do is press OK. Everything should be fine. And then Fusion will go ahead and generate our toolpath for us. So it's nice and simple. And as always, we simulate just to make sure we don't do anything stupid and to make sure that everything looks fine. So we'll slow it down. And another thing that I like to do is just use the timeline here, because it makes things a little easier sometimes, just to make sure that, again, you're not doing anything stupid. It gives you some fine control. So I don't see anything there standing out. We'll go ahead and go to the beginning and just press play. Speed it up a little bit, and there you go. We're making our soft jaws. Nothing too spectacular, but again, we made sure we didn't crash into the vise or into our other soft jaw, so that was the main aspect there. Okay, so what I will do now is go ahead and exit the simulation, and then now that we have our soft jaw roughed, we just need to come through and do a contour to go ahead and finish the sidewall. So we'll do that now. We'll go to 2D contour. So we could press the button here or use the drop down menu. And for my finishing tool, we'll go back to the tool libraries. I like using the 3/8 Gorilla Silverback, so we'll select OK. And for the speeds and feeds, we're running at 7,500 RPM. We're finishing, so we're going slower, 30 inches per minute. And that gives us a little over 1 thou per tooth. There's the surface foot per minute if you're interested. We'll now go to our geometry. I'm just going to select this contour. And then what I will do is go ahead and go to heights. We want stock top. It just so happens that that is fine because in this case our model is the soft jaw and we're not surfacing the top of it, so stock top is fine, and the bottom height is our selected contour, so that all looks good. We'll go to passes. Normally when I'm finishing, I always enable smoothing and feed optimization, so all that looks good there. All right, go to linking. I usually change my lead-in sweep angle to 45 degrees just out of habit. So we'll do that. We'll press OK, and then we'll simulate. Again, just to make sure we don't crash our machine and make sure we don't run into any issues. All right, so I'm already seeing a problem. So it looks like if we were to machine this, I would miss some stock right here on the edge. So I'm going to exit this, and then what I'm going to do is go into edit, and this is easy to solve. I am just going to enter a roughing pass. So roughing passes, we want to change our step over to be 50% the diameter of the tool. So we'll do that, and I think we were only going to need one roughing pass. Okay, there we go. So now if we go back to simulate, you will notice that we indeed, there we go, we indeed get all of the stock and we don't leave anything behind. So that's good, that's perfect. So I think that does it for the cam side of things. And so the last thing I want to do before I forget is just go back in here to our 2D contour, go to passes, and make sure that we change our compensation type to wear. That way, if we need to adjust the diameter of our end mill to make sure that we have nice tolerance here to fit our part, we can do that on the machine without coming back in and regenerating our G-code. So that does it for this tutorial. We'll now get into the machining of the soft jaws. So I hope you enjoy. Alright, here we are back at the machine about to make the soft jaws. I have my 1, 2, 3 blocks giving me a 3-inch jaw gap, so that's what I will use to make sure my jaw gap is perfect for when I go to mill my soft jaws. So let's go ahead and start that. Alright, so here we are back at the machine. I'm going to go ahead and press the find corner button. So let's go ahead and do that. And now we should go ahead and move in, probe the corner, or probe the side, sorry, move back, probe the other side, and there we go. That was it. Now what I'm going to do is just go ahead and probe the upper surface. I probably won't record that since that is just a very simple button press. So I hope that helps. So here we are again at the machine. I'm just going to go ahead and press that button. We move down, set our coordinate. Alright, so now we're ready to go ahead and load our G-code and begin making our soft jaws. Alright, so now we jump in and do the roughing of our soft jaw with the 3/8 Gorilla Chimp Breaker, 60 inches per minute, 1/4 inch depth of cut, and our optimal load is 30 thousandths. We're using flood coolant here so it starts to get on the GoPro. I think eventually I'm going to make a GoPro case, with an air knife just to make sure we brush the coolant off. So now we finish up our soft jaws with the 2D contour. This time we're using the 3/8 Gorilla Silverback, 30 inches per minute, 1/4 inch depth of cut, and we're just removing the stock from the sidewall, so that was 20 thousandths. And again, sorry for the coolant all over the camera. Anyway, that does it for our soft jaws. Thanks for tuning in. Please like and subscribe.